Hello. The purpose of this lecture is to go over the variance components in analysis of variance statistical analysis. So specifically, I'm trying to talk about how variance is partitioned between total, between groups, and within groups, as well as defining what's explained and what's unexplained depending on the type of ANOVA you are running. So the first we're just going to go as a quick review. We have the all F ratios in general, so that means all ANOVAs are specifically defined as the explained variance over the unexplained variance. And what's defined or delimited as explained and what's delimited as unexplained differs based on the type of ANOVA you're doing. Just as a reminder, we really have 5 major classifications of ANOVA. The first one is based on the number of independent variables, where in this situation we have a one-way one independent variable, and when you have one independent variable, you can either break it up into independent groups, where people are tested independently, or repeated measures where people are tested repeatedly. The second greater classification of ANOVAs, as you'll see here I have a typo, so we're going to scratch it out, is not repeated measures, but it's factorial. And a factorial ANOVA is based on the concept that you have at least two or more independent variables. And when you have 2 or more independent variables, they can be both or all independent groups or independently measured. They can be all repeated measures tested, or they can be some combination of independent groups and repeated measures, and we call those a mixed factorial ANOVA. So we're going to go through the partitioning of variance for those types of designs in the next couple of slides. First, when we look at an independent groups ANOVA, what we have here is whenever you see the blue is going to refer to explained variance, and pink is going to refer to unexplained variance. So in general, you're going to see this F ratio will always be blue to pink. Now in a one-way independent groups ANOVA, the explained variance is what we're going to label as between groups variance. So what's different between the groups of our independent variable. Our unexplained variance is our within groups, how groups within each level of the independent variable differ. So one-way independent groups ANOVA, our between groups variance is explained, our within groups variance is unexplained. Now, in a factorial ANOVA, that still stays the case, where our between groups variance is what's explained, but we're partitioning that further into an A main effect, a B independent variable main effect, and an A-B interaction. And in each of those situations, A, B, and the factor A, factor B, and factor AB are all explained, and they are all between groups. Then you have this pink part, the unexplained, is your within groups in independent groups ANOVA. This all switches when we get to a repeated measures component. In this repeated measures component, now what we have over here is partitioning where everything here is considered within groups. This part is considered between groups. Between groups in this situation is really a constant that gets removed out of the equation. We don't even include it. So it's not going to be considered a part of our analysis. Our within groups explained component is going to be the within groups treatment, so the differences in your groups due to your treatment, and then our unexplained is our within groups error. So our F ratio will be the within groups treatment over the within groups error. The same stays true when we get to our factorial. The between groups component remains to be a constant that is otherwise removed from the analysis, so we don't include it. That's my between groups. My A factor, my B factor, and my AB factor are all considered within groups component of a within groups treatment. Within groups. And then my error is also within groups. So my F ratio for my factorial repeated measures ANOVA will be my A within groups over my error within groups, my B within groups over my error within groups, and then my interaction will be my AB within groups over my error within groups. Then repeated measures, it gets a little bit more tricky, where if we have an A variable that is, in this situation, our A variable is independent groups, and our B variable is repeated measures, the part that's going to be considered between groups is going to be the A variable. The part that's considered repeated measures will be our B variable, because it's repeated measures, it's going to be within groups. Anything that has, everything defaults to the within if any one of the variables is repeated measures, so that means our interaction is also going to fall as within groups. And then our error here is also, as it always has been, within groups. But our F ratios will remain the same, where what's explained by our main effect for independent groups is explained, what's explained by our repeated measures main effect is explained, our AB interaction is explained, and the only part that's unexplained is within groups error. The biggest difference in a mixed factorial is to notice here that everything here, the B factor, the AB factor, and the within groups error are all considered within groups. And that's it. I hope this became helpful in your review of understanding what's explained and what's explained in your different types of ANOVAs.